Okay, for anyone who is still confused because of my botched example this morning, I'm going to attempt to clarify this a little bit. The explanation, which I was struggling with this morning, is actually very easy, and question number 2 kind of leads you right into it. So I'm going to attempt this. If you want to watch it, definitely give it a shot. If it doesn't make sense, ask Elena. She'll explain it better than I will, probably. But if we look at question number 1, it says the company's manufacturing rivets, and they believe the shear strength, okay, is modeled by the normal curve with a mean of 800 and a standard deviation of 45, and they want to know about what percent of these rivets would expect to fall below 870 pounds. What that means is, what percent of these rivets, okay, have a shear strength less than 870 pounds? That means that if we were to apply a weight of 870 pounds to them, they would fail. They would break, okay, split, however you want to describe it. The ones above that, okay, those would actually hold. So when we look at that on the normal curve, what we're saying is that we know that the mean is 800. We have 870 pounds. We want to know what percent of the rivets manufactured fall below this weight. Again, that's the percent that if an 870 pound force was applied to them would fail. That means that these would hold. Okay, so what we need to do is we need to find this z-score that corresponds to 870. Alright, and then we need to either use our chart or our calculator to then find out what the corresponding percentage is. So the formula, z equals x minus x bar over the standard deviation. So z equals, in this case, x is 870 minus the mean, which is 800, divided by 45, gives us a z-score of 14 over 9, 1 5/9, 1.5 repeating. So then we go to our calculator, and we want to find the area to the left of this curve, because they fall below 870 pounds, the shear strength less than 870 pounds. Second distribution, normal CDF, our lower bound, we use negative 99. Our upper bound, we're going to use that z-score of 14 divided by 9. And what we see is that 94% of the rivets, okay, have a shear strength less than 870 pounds. And that should have led me today perfectly into this next question, because it says that an individual wants to use particular rivets in a situation that's requiring a shear strength of 725 pounds. So anything that has a shear strength greater than 725 pounds is good. All right, we want that success, or we want 95% of these rivets to satisfy, okay, that condition. So if we were to do the same thing we did on question number 1, so we have our normal curve. It doesn't look very normal. It is. Again, if we were to say, okay, well, what we want is we want 95% success. I guess the 95 would be 95% of the rivets here. Okay, and we had a value of 725 here. That means that 95% of the rivets have a shear strength less than 725 pounds. That means they would fail when a pressure or a weight of 725 pounds was applied to them. We want the exact opposite. We want only 5% of them to have a shear strength less than 725. So what we need to do is we need to reverse this curve. And this is what I didn't do today. Okay? So what we want is we want 95% of the rivets that we manufacture to have a shear strength greater than 725. We only want 5% of the rivets to have a shear strength less than that. So this is the value we need to use to find the corresponding z-score. So to do that, inverse norm 0.05, corresponding z-score is approximately negative 1.6. So that's the z-score that we should have used. Negative 1.6 equals, okay, we're looking for a mean, so 725 minus that mean divided by our standard deviation of 30. So what we would do is multiply this value by 30. We would subtract 725. And then we would divide by negative 1. So we get approximately 774 pounds. Now for the last question, what we had here didn't work, so we changed this to 752. Again, it would be impossible with 845 or whatever we had there, because again, we want 98% of the rivets manufactured to have a shear strength greater than 845. But again, if 775 is here, that means that 845 has to be somewhere over here. There's no way that we can have 98% of these rivets manufactured have a shear strength greater than this. This has to be over here, so it needs to be less than the 775. That's why we changed this back to a value of 752. So when we look at this, we have a mean of 775. Okay, we want to success 98% of the rivets manufactured to have a shear strength greater, okay, than 752. So again, 752 is going to need to be here so that 98% of the rivets have a greater shear strength. Shear strength is increasing here, decreasing here. So that would leave us with 2% of the rivets allowed to have a shear strength less than 752. So we would do the same thing, inverse norm, 0.02, not 0.98. So we get approximately a negative 2.05 equals, so in this case we know that we want 752 minus 775 divided by the standard deviation. So when we would do this calculation, 752, actually let's put this in parentheses, 752 minus 775 divided by second answer, and we get approximately 11.2 pounds for the standard deviation, and that's the way that problem should have been done. So you can watch this, hopefully it brought a little bit of clarity to it. If not, again, I apologize. You can stop by after school or ask Elena. I think she's in the library 7th period. Track her down. Alright, so hopefully that helps.